go live, you'll see, you'll get like a little green up arrow when we're ready to go. Steve, you might want to mute when you're done talking too. Welcome, everybody, to the final day of the AquaWatch Biennial meeting. We did just have a couple of announcements. First of all, I'll place in the chat the link to the upcoming Ocean Optics Conference. A reminder that abstracts are due, I think, April 4th. Is the deadline for that. I will also place a link to the Miro board or Miro board, however we're pronouncing that. And we hope that you will utilize that. And Steve, you have any announcements? Thank you.
Yes. Thanks, Mary Beth. And again, welcome to day 4. We've had a great week and productive week, and we're going to finish strong here on the last day. So the only announcement I wanted to make is the upcoming validation workshop that we talked about on and off this week. And if you are interested in attending this NASA and slash AquaWatch validation workshop, which is going to be held here in Madison, Wisconsin in June 7th and 9th, we request a kind of letter of intent or letter of expression of interest. And you can, I can put that link in the chat and or go to the AquaWatch website and you'll find the link. But those are due March 31st, and that's why we bring it up. So it's open for one more week. So please get your name in there if you're interested in attending. And with that, we'd like to move on to today's sessions. And I have the honor of introducing Anthony Gududu. He's an associate professor at Makerere University in Kampala, Uganda, where he's, again, associate professor of informatics with an interest in environmental and machine learning applications of GIS and remote sensing. So with that, I'm going to turn it over to Anthony.
Thanks, Steve, and a very good morning to you all, and to others, a very good afternoon, and if there are probably others, a very good evening to you all. I would like to take this opportunity to thank you for the privilege of sharing the work that I have been doing on Earth observation for water quality monitoring on Lake Victoria, which is in Uganda. Actually, it is in the middle of Africa, and it's a transboundary lake surrounded by Uganda, Kenya, and Tanzania. From Makerere University, which is in Kampala, the Department of Geomatics and Land Management, and amongst the other things I'm interested in is remote sensing for marine applications. A bit of background. Lake Victoria is the largest freshwater body in Africa and the second largest in the world. It is about 68,800 square kilometers. In the next slide, I will make a comparison with the US lakes because square kilometers may not be familiar to many people. It's probably more famous for being the source of the River Nile. As I mentioned earlier on, it's a transboundary lake, and as you can imagine, it supports the livelihoods of, over 200 million people directly and indirectly. So when you look at the Lake Victoria Basin through to the Nile Basin, from Uganda moving northwards to South Sudan, Sudan, and Egypt, that is easily over 200 million people supported directly or indirectly through by Lake Victoria. As you would imagine, it's a source of fish, potable water, water for agriculture, recreation, religious practices, supports flora, fauna, ecosystems, and various other ecosystems. And compared to lakes in the US, I got this off the internet, and Lake Victoria, it would be smaller than Lake Superior and larger than Lake Huron and Lake Michigan. So that's just to give a bit of context about the size of the lake that we are dealing with. And so the challenge at hand that we have is, first of all, its enormous size. It's actually bigger than a number of countries. So you can imagine how big this water body is. It's transboundary, and that presents its own challenges. We have different authorities concerned with monitoring water quality. Be different, and because there are different countries, different organizations, there are different protocols. Invariably, they all use traditional means of measuring water quality. So, and I'll be showcasing some of them in this presentation. So you have cases where we have to go to the lake, collect our water samples, and there are water quality parameters we can measure in the lake. There are others which we have to take back to the labs for further processing. This, as you can imagine, is expensive, time-consuming, cumbersome, and whereas these in-situ measurements are accurate, or very accurate, they are actually limited in space and time. So we are only sure of the accuracy that we have collected at the time of data collection. Anything beyond that, we will have to make approximations or make predictions. So it is on account of this that we thought we would leverage Earth observation to be able to collect water quality information, because of the various advantages that would accrue from it. For many of us, we would appreciate that, it has opportunity for synoptic coverage instead of collecting data at a point. Potentially, it can give us accurate information. And the beauty of Earth observation data is that we also have access to archival data and can also integrate it with other data sources. And especially of importance to us here in Africa, there's a lot of freely available imagery that we can leverage, we can use, we can explore, which we can harness as we seek to explore the use of Earth observation for monitoring water quality. And so essentially what we're trying to do is to relate our various water quality parameters to what we can get from a pixel, or what in other spaces we call biooptical modeling. So through biooptical modeling, we'd like to get an impression about the temperature, about the transparency, about other water quality parameters. Of course, especially for us who work with inland lakes, there is a challenge. There has been a challenge for a long time about the accuracy of existing algorithms. Many of them were traditionally started or developed for the oceans, and some of them have not necessarily worked when translated to inland lakes. And so a lot of what we're trying to do is, if we are going to get buy-in in the use of Earth observation for monitoring water quality by the various stakeholders, we need to assess these algorithms. And we also need to build capacity on how to develop algorithms unique to our lake situations. Work we have done so far, our initial work has mainly focused on correlating satellite-based retrievals with in-situ retrievals. And this has involved going into the lake and collecting in-situ water quality parameters to compare with what we can derive from the satellites. We have looked at temperature, chlorophyll, air, water clarity. We also have, of late, collected in-situ spectral reflectances as well as color. And shortly I'll be showing you a video about our most recent excursion. And so this is a breadth of sort of the instrumentations that we have been able to do. For those of you who are into water quality, you'll recognize a Van Don sampler to the right there. This was a big vessel, so we're able to do some initial processing aboard the vessel. Here we were collecting samples that we could later on process for chlorophyll A. And at the bottom, we were trying to explore the use of a spectrometer to collect spectra. And so what have our workflows looked like? We have carried out a couple of expeditions to date, probably 5. It's an expensive venture, so we are not able to cover as many expeditions as we'd like. And we have initially been looking at mostly MODIS imagery, which has a sample that we are at least 1 kilometer away from the shoreline, and each sampling point is at least 2 kilometers away from the other. And at each sampling point, we would collect our GPS coordinate, measure the temperature, the circuit depth, collect a sample, do some preliminary filtering on board, and then take it to the lab for processing. And essentially, we have been purposing to collect our samples 3 hours before the overpass, which we are, of course, able to deduce from the NASA website. And of literature is, I mean, different people have used different sequences. Some have used 2 hours before and after. We thought 3 hours before and after would give us about 6 hours on the lake, which is probably more productive use of our time. Of late, we have also started exploring Sentinel-3, and here I would like to play out a clip of a very brief clip about our most recent expedition on Lake Victoria, and yeah. Yeah, so here we were on this is one of the vessels that we have used going to the lake, collecting our samples, and we did this work in collaboration with the University of Oldenburg in Germany. We have a colleague there with whom we have been working with, and yeah, so essentially you get your sample and store it here. We didn't have space to do any processing aboard the vessel, so we had to store our samples and later on proceed to do the processing in the lab. I will fast forward to so that we don't have to go through all of this. Oh.
Looks like we've lost your presentation.
Let me, yeah. At least we haven't lost you. I was afraid that. Let me just do it again.
Sure.
It sometimes can take a couple seconds. There you go. Good.
Okay. Yeah, I hope you can see that.
Yes, we
Yes.
do. We hear it as
Yes,
well.
we're fine.
Yeah, so these are some of the algal blooms that we can see in the middle, in the middle of the lake. And yeah, this is the sort of stuff that we would like to be able to measure. This is how we're doing the sec depth, and these are some of our trained scientists that we're also trying to groom an interest in marine remote sensing, but of course needing an appreciation of in situ data collection. And closely related to this is the Forel-Urel scale. We're looking at watercolor, and again, yeah, so we're trying to have as many people take the measure. And we've also been interested in and this was in our latest expedition. We're trying to look at microplastics. So we're trying to collect samples on the surface of the water. And in this case here, we're demonstrating how we also were interested in picking samples at the bottom of the lake. In spite of the size of Lake Victoria, it is actually considered a shallow lake. So our deepest point is around 80 kilometers. So here was around 80 meters, sorry. So here we're talking of around 60, 50 meters. So we wanted to see, we wanted to explore the issue of microplastics and see how far or how prevalent it is both at the surface as well as at the bottom. And we also were taking radiometer readings on the lake. And actually, for this expedition, we have processed this data and we are in the process of publishing it in Pangaea so that there's a wide usage of the imagery. That was a particularly pleasant day, as you can see, clear blue skies. If you have gone for these expeditions, it's not always guaranteed. And of course, at the end of an expedition, that is how that expedition ended. So we have done a couple of expeditions on Lake Victoria. This is not the exhaustive link. We have mostly done the work on the Ugandan side of the of Lake Victoria. We hope that we can expand this to the whole lake so that we're able to have a data set covering the whole lake, which we can use and be able to share with other scientists who would like to leverage this data for improved algorithms. When we're doing this work, of course, there are various challenges. Being astride the equator, cloud cover is always a challenge. It's not unusual to go to the lake, collect data, and when you source the imagery, at the time of satellite overpass, cloud cover was a challenge. We've also had cases where, the image, is just outside your area of collection. That notwithstanding, we have been, these are some of the results that we have leveraged over time, trying to see some time series assessment. This is annual averaged images, and this sort of stuff that we're hoping we can share with the various stakeholders. Of course, this can be done annually, it can be done seasonally, and we're hoping that we can add this to we are hoping that we can share this with various stakeholders. This was chlorophyll A, and here we converted that into trophic zones. And we think that, for some of the stakeholders, this may be more valuable than the satellite derivatives as they are. We have also tried to go into explore modeling, trying to see if we can have some models, but of course we need to collect more data. And this looks the way it is because it's averaged over a year. This is data of a particular date or day. So there will be cloud cover, and that's why it would be looking like that. Upcoming work, we hope to come up with a couple of publications regarding the most recent work that we have done, and we are actively processing. We want to process all our data and have it probably Pangea or Pangea, I don't know how you pronounce it, so that the data is available to as many stakeholders as possible. We have data that we have collected for the past probably should be coming almost to 8 years. So we have coordinates, we have processed chlorophyll A, we have Seki depth. More recently, we also had nutrients that we tested for. And we think that there are people who could use this data way beyond what we hope to do. We also hope that we can be able to carry out more extensive in situ observations, particularly for spectral reflectances. And for people who are in this area, you will appreciate the need for specific atmospheric corrections. We also, for ourselves, have come a long way. So there's also the aspect of capacity building, both at supervisory level, but also having more students being able to harness this data. We are looking at developing training material on marine remote sensing. We want to explore possibilities of, say, running a summer school or running a short course on marine remote sensing, so that we can broaden the scope of people who are able to use this data. Ultimately, our aim is to operationalize the use of Earth observation in monitoring of water quality on Lake Victoria, and hopefully we can upscale these lessons to other water bodies. As you can imagine, East Africa is also known as the Great Lakes region because there are numerous lakes, and we are hoping that from the lessons learned on Lake Victoria, which we are actually using because it's just next door, it's just here. We hope that we can apply these techniques to other water bodies. These are some of the publications that we have derived from the work that we have been doing on the lake. Most recently was with the Journal of Great Lakes Research, and it's about empirical modeling of chlorophyll A from MODIS satellite imagery for trophic status monitoring of Lake Victoria in East Africa, and a few other publications that we have generated. Thank you very much. This is a typical sunset on the lake, and I'll be happy to field any discussions. I hope I'm still within the time. Thank you.
Yes, thank you, Anthony. Very good. I appreciate it. If anybody has any questions, again, they can type it in the Q&A, or you could raise your hand now since we have a few minutes, if you'd just like to ask the question directly, verbally. Just one question from me, Anthony. What do you see as some of the barriers, I guess, moving forward? You talked about your plans in the future here, but are there issues or problems, be it with, equipment, be it boats, or more on the funding side, or getting properly trained students? of course, there's another, it can be a number of obstacles, and
Actually, you have enumerated the challenges, but yes, among one of those which you haven't mentioned is getting the stakeholders to trust that this data is accurate, is reliable, that they can use it. It can complement their activities. If somebody is tasked with monitoring water quality on the lake, they don't have to wait for the next expedition, which may be 2-3 months. So in between those detailed expeditions, we can still get an appreciation of the water quality, and we want to give assurances about the efficacy or the reliability of the satellite imagery. And so for us to be able to do that, we need to be able to have accurate results. We need to be able to show that what we're getting from space is comparable to what they're getting or can be relied upon as they await their expeditions. We, of course, for vessels, we collaborate with one of the partners. We call them Nafiri Fisheries Institute. So they have some sea-going vessels. And they have the the captains who have the experience for the high waters. In the middle of the lake, it can be very challenging. Given the size of the lake, you get to places where the waters are rough. So yeah, in terms of skilled personnel, that is not a problem. But it's the funding. Every expedition is quite costly. So yeah, those are some of the challenges we have. But also, we also need to build the capacity. We get to cases where we train students, and after that, they have built the knowledge and they go on to other activities. But we need to provide incentives for them to continue advancing this knowledge so that we can also build our local capacity, our local knowledge in being able to harness the satellite technology. So yeah, funding, need to build capacity of our students to be able to work at a high level, and also, getting buy-in from the local stakeholders.
Okay. Thank you.
Steve.
Mary Beth, I see you come in on stage.
I did. I just wanted to, as I was typing my question, which is in the Q&A, you were answering it, and it had to do about the trustworthiness of the data. And I'm just wondering if you could elaborate on that. For example, is there, and I did include it in my question, whether or not there was any sort of interest in branding the information that you share, or in getting information that you share branded. So the concept that we've been discussing is how much investment would like if satellite information was provided by a major space agency, Copernicus or NOAA or NASA, and then information was contributed by a local government. Perhaps the in situ data that you were showing was being collected, or cell counts for algal blooms or something like that. And then you put out a product or an information bulletin or something like that that was then branded with your university's information. Would that be better received? It's 80%. It's 80% a Copernicus product, but then you added another 20% that was local and value added information. Would that be enough to elicit trust, or does it need to be much more of an investment for trust to be built?
I think that's a very interesting concept. We haven't explored it, but I think it would go a long way. But even before it is accepted, they would still revert back to us and ask us, "Yeah, you are the people who do this stuff. Can we rely on it? I think the advantage we have is that even when we go for these excursions, we are dealing with their labs. So when we go to collect the samples, we are actually using the government facilities to do the water quality testing, and some of their scientists are part of our publications, are part of our meetings, and so I guess the branding would, at this point in time, would go a long way in improving confidence in some of these of these products. So I would see us as sort of a go-between between the stakeholders and the branding organizations.
Okay.
Yes. Yeah. And eventually it might be, you know, you might be able to do.
I just want to say there's a number of other questions here. So can you hear me, Anthony?
Yes, I can hear you.
Okay, there's a number of other questions here, just quickly because we're at the end of the hour, but and some of them are related, but could you tell us, just touch on the cooperation between the various countries for management of Lake Victoria, and do you collaborate in terms of collecting water quality data across the whole lake?
Not as much as we need to. One of the, what should I call them? We would want to piggyback on one of the ventures. The fisheries organizations in the three countries annually collect various water quality samples. So we would like to one time piggyback on them and especially collect spectral reflectances of, as they're doing the excursions. It goes on for about a month. Depending on how we play our cards and availability of funding, we may be able to piggyback on them this year. Other than that, we are unfortunately working in silos.
Yeah. Okay. Well, we're already 1 minute past the hour, and I'm sorry, Janet, we're not going to get to your question, but I'll just quickly read it, and then maybe you can discuss it offline. But she's interested in, when you operationalize this effort, what kind of approach would you use, be it empirical, machine learning, or semi-analytical algorithms, and are planning on using open data cube platforms?
We're at this stage, we're open to every opportunity.
Okay.
And every partnership.
Okay. Well, thank you so much, Anthony, for speaking today. This has been great. It's good to hear about work going on in other, corners of the world, and we really appreciate it. And so I'm going to officially close this session, and so I ask you to go back and go into the next session. Thanks again.
Thank you. And thanks for coming. Thanks for being here.